Hello, everyone. A very good morning. Dear authors and invited guests, welcome to Technical Session 5E. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the ninth International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held today uh, through Zoom on 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentations and 2 minutes for questions and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. So before we get started, I'd like to introduce our session chair. Um, hmm. So Mr. Shengyun Zhao, sir, is an assistant professor in the School of Architecture and Built Environment, UCSI University, Malaysia. Our second session chair is Dr. Astha Parikh. Ma'am is an assistant professor at for CS and IT in IIS, deemed to be University, Jaipur, India. Welcome to this session, ma'am and sir. So moving on next, I'd like to start with the presentations. I'd like to call Mr. Santosh Nirmal for his paper titled Adversarial Attack on Deep Learning Model Electricity Theft Detection Model. So please can you start with your presentation?
Thank you, ma'am. Good morning, everyone. My name is Santosh Nirmal. Ma'am, am I audible? Hello, ma'am. Hello,
Yes,
hello.
sir. Yes, sir.
Yeah, okay. Good morning, everyone. My name is Santosh Nirmal, and my presentation topic is adversarial attack on deep learning based electricity theft detection model. So these are the some outlines of this presentation. Adversarial attack, what are the types of attacks, evasion attack, at which stage it performs, and the attack on energy theft detection model, which is a proposed system, and what are the effect of attack on the ETD model. Then performance analysis and references. So adversarial attack are those malicious attacks on the data which may seem okay to human eye but cause misclassification in machine learning. If you see in the diagram that if this is stop sign and when add some adversarial noise, we will get a result something different than the actual expected output. So it may be dangerous. It can cause accident. So these are the why adversarial attacks are performed. The attacker's goal can include confidentiality. It acquires the private information by querying the ML model. For example, stealing the classifier model's information, then integrity, cause the machine learning model to perform incorrectly for some or all inputs. Example, causing an ML-based malware classifier to misclassify a malware files as benign. Then availability, cause the ML system to become unavailable. For example, generate malicious session which resemble regular network traffic cause MS system to classify legitimate traffic session as malicious and block the legitimate traffic. So these are the types of attack. What kind of attack are there? There are basically broadly three categories based on the outcome, based on the knowledge, and based on the stage. Based on the outcome, there are two attacks. One is targeted attack, another is non-targeted attack. Knowledge base, there is a white box, black box, and gray box attack, and a stage at which stage it is performing. Training stage, it is poisoning attack, and at the testing phase, which is evasion attack. So I created the attack at the testing phase, which is also known as evasion attack. I created an algorithm where I generate the adversarial data and it craft on the model. I'll explain it in next 2 3 slides. So Black box attack. In the black box attack, there is no access to the structure of the network model. In fact, the attacker doesn't have any information with him about the model, and it is the most difficult attack. Next one is gray box attacks, in which a little bit information available with the attacker, and mostly the adversary is expected to craft adversarial samples on the surrogate model of the same architecture. And white box attack, which is the strongest adversarial, in which attacker knows almost everything about the model, and it is very easy for attacker to perform such kind of attacks. So in non-targeted attack, the goal is to mislead the classifier to predict any label other than the ground truth label. For example, when we add perturbation in the cat, we get any output other than the cat. And in targeted attack, there is a specific goal to mislead the classifier to predict a targeted label for an image different from the true class. For example, when we add perturbation to the cat, the attacker wants a specific output, like predicted, it should be predicted as a dog. So data poisoning, which is performed at the training phase, it includes insert malicious inputs in the training set, modify the input instance in the training set, change the labels to the training input, and then evasion attack, which is performed at the testing phase. Attacker do not tamper with the ML model, but instead it causes the produce adversarial inputs. Here, basically, what happens? Attacker generate the adversarial data, which then apply on the model and get the expected output. So for the model, I use the data set which is available on agcc.com.cn website. It is a state-graded corporation of China electrical consumption database. It is freely available. It contains basically 2 years data, having more than 40,000 total consumers, out of which 36,000 are normal consumer and remaining are fraudulent users. Sorry. So this is the consumption pattern of legitimate and false user. You can see in the in below graph that there is a very less I mean very down, or what we can say, it shows as a low consumption for a long time. It can be easily said that that must be something fishy, or problematic. That consumer may be problematic because there is a very low consumption of the electricity. But this is not the only case, because there are a lot of other scenarios are there, like the door is closed for a long time, or winter season is there, because in winter season there is a consumption low as compared to the summer season. So such kind of cases should be considered. But broadly, we can say that if there is a low consumption for a long time, then it may be a fraud user. So this is the proposed energy theft detection model, in which we take the data from the data set. After analysis and processing, pre-processing, we divide it into the training phase and testing phase. We pass the training data to the model to train. That the model is CNN AdaBoost hybrid model. And then we calculate the performance of the model in terms of accuracy and other parameters. If you see that CNN CatBoost achieves almost 94% accuracy, which is quite high as compared to the other methods. And this is a graphical representation of this parameters. And we perform the adversarial attack, in which we craft the adversarial data which is generated through the algorithm, and then we pass it to the prediction model and find out whether there is a degradation in the performance of the model or not. So this is an algorithm which is used to generate the adversarial data, in which we have a sample, target, label, loss function. Here we initialize the perturbation and initialize the sample. Through the n number of iteration, we produce a more optimized adversarial examples. And these adversarial examples are then sent to the adversarial model, and try to get the performance of the model. So there are specific parameters are there, like detection rate, which is also known as true positive rate. It measures to determine the proportion of the actual positive instances identified correctly by the classifier, and false alarm, which measures that that helps to determine the proportion of negative instances that are incorrectly classified as a positive by the classifier. And accuracy is a ratio of prediction, correct prediction to all predictions. So here one thing we should note that for consumers, in order to get more profit, consumption can be reduced more, but it can be easily detected by the model. But by keeping the minimum profit, it is very it is high possibility that the model can treat that particular consumer as a legitimate user, because if there is a huge difference between the actual or real sample and fraud sample, then it can be easily detected by the model. So by keeping the minimum profit, more and more fraud consumers can easily force the model to treat them legitimate consumer. So this is the proposed attack on different method on CNN catboost. It degrade the performance, it degrade the accuracy of the model up to 88.54%. That means there is a almost a 7 to 8% degradation in the accuracy of the model, and which is quite still better when I tested with other methods. And we can say that the attack is successfully reduce the performance of the model. So this is an ablation experiment in which I remove the cat post and try with only CNN model. But the accuracy after the attack is also degraded, and which is quite less as compared to the hybrid model. That's why I choose hybrid model for energy theft detection. And these are some advantage and disadvantage of this adversarial attack. One is performance can be tested. We can test how the system is more how the model perform under the attack. How we can system can become more robust. It can be utilized across various industrial sectors. Like we can use it in credit card fraud detection. The disadvantage of this energy theft detection and adversarial attacks is that it increases the processing time. At it use a hybrid model, it takes some more time to energy to detect and
Excuse me, sir.
okay. Yes,
Sorry to
ma'am.
interrupt,
Yes, ma'am.
but 9 minutes are over. Can you please wrap
Okay,
up?
ma'am, it just finished. This is the
Yeah.
last
Okay.
slide, ma'am. Last slide. Okay, and these are the conclusions. Here we study the different attacks and we craft the adversarial data on the DD model, test the performance of the model. So that's all from my side. Thank you, ma'am. If there are any questions, please ask.
Any questions from the session, sir?
What are the challenges you faced?
Ma'am, basically the challenge I have gone through the cat boost algorithm. First, I tested the ADA boost, but it is difficult to implement. Cat boost, they have some specific functionalities like cat boost classifier is there, and most important thing is the data. The data is data lot of null and blank values are there. So such kind of difficulties I faced during this study.
Okay.
Okay.
Okay. Thank you, sir, for your presentation.
Thank you so much, ma'am, for giving me this opportunity. Thank you.
Yes. Moving on next, I'd like to call Ms. Jyotsna Parmar for her paper titled Critical Analysis of Various Evaluation Techniques for Text Summarization. Ma'am, can you please start with your presentation?
Okay, ma'am. Yes. Is my screen visible to everyone?
Yes, yes. Please continue.
Okay, ma'am. Hello, everyone. I'm Jyotsna Parmar, and I'm here to present my paper on critical analysis of various evaluation techniques for text summarization. So let us begin with it. Now, what is the goal of doing this critical analysis? First is to provide insight into different available evaluation techniques for automatic text summarization. All of them have been mentioned in the paper. Second is to provide critical analysis of all available automatic evaluation techniques like word score, Meteor, ELU, Route 1, Route 2, and Rougel, because these are the automatic evaluation techniques. Third is to suggest best available evaluation technique as per custom needs, because for different types of text summarization techniques, different types of evaluation techniques are needed. Coming on to the brief introduction about text summarization, it means generating a smaller variant of a large document containing important information using concise and simpler sentences. It is broadly classified into two parts. First is extractive and second is abstractive. Extractive summary, it makes use of sentences that are already present in the source document for generating summary, while in abstractive summary, it is mainly focused on creating new sentences using knowledge available from the source document. So it is abstractive summary is more like of a more kind of human-like. So earlier in the research area, more focus was on extractive summary. But now, due to the advent of pre-trained transformer models, the trend of automatic text summaries has shifted from extractive to abstractive summaries. So due to the absence of now, we have absence of accurate semantic similarity measurement techniques. And so the evaluation of automatic text summarization techniques had been a very challenging task for the researchers. As a result, the most popular evaluation technique, Rauch, is not able to do the right justice to the evaluation of text summaries. Now, coming on to the basic evaluation techniques, they are broadly classified into extractive approach and content-based approach. Extractive approach, this method of evaluation checks on whether a sentence is present in ideal summary or not. So it is actually for extractive summaries because there is an identical match. So we can tell that the sentence is present and not present. So it is measured in by using three measures like precision, recall, and F-score. Precision is defined as the number of sentences that appear in both the automated and referenced summary divided by the number of sentences in the automated summary. Recall is measured by the number of sentences that are present in both automated and referenced summaries divided by the number of sentences in the ideal summary. F-score is actually the best among the two because these are somehow biased. So it aggregates both precision and recall. It is actually the harmonic average of precision and recall measures. Coming on to content-based approach, this method of evaluation compares the words in the sentence rather than the entire sentence. What it actually do is actually break the sentences into tokens, and these tokens are being compared with each other. Now, some of the content-based approach, the most popular one is Rauch. Rauch evaluates summary by determining the number of overlapping units between automated and ideal summaries. So it is actually identifying the identical tokens. Happy and cheerful are different words for Rauch. There are two variants. Some more variants are there. The most popular ones are Rauch N. N here determines n-grams. So for unigram, Rauch 1 is there. For bigrams, Rauch 2. And about Rauch L determines the longest common subsequence between the two summaries. So it computes the ratio between longest common sequence between the two automated and reference summaries and the size of reference summary. The next is pyramid method. It is actually a manual technique. So as for me, a manual technique is not a good fit for automatic, for evaluating automatic text summarization technique. So, because it requires human annotators for identifying summarization content units. Coming on to cosine similarity, it is used to measure the similarity between vector representations of the sentences of the generated and reference summaries. Another one is BLEU score. What it does, it measures the similarity between the generated and reference summaries based on n-grams, unigram, bigram, trigrams, and so on. Next one is Meteor and BERT score. They are actually more suitable for abstractive summaries. Meteor score is calculated by using F-score, which is based on matching of unigrams, and there is a penalty function for wrong word order. The match between the words is based on exact match. So when tokens are matched between the two sentences, it is based on exact match, synonyms, and morphological variants. But it has a disadvantage, which we'll be discussing in next slide. Coming on to word score. Word score, tokens in the candidate sentences are compared with token in the reference summaries like all other evaluation techniques, but it makes use of contextual embeddings or vectors for calculation of similarity between tokens. It actually takes the context of the word in account for calculating similarity. Like the most common example is bank. Bank can be the financial organization or the bank of the river. So it actually identifies the context of the sentence by checking other tokens also. Now, coming on to the data set, for our critical analysis, we have used the most popular, the benchmark Microsoft Research Paraphrase Corpus dataset. So, and it is used for comparative analysis of various techniques like word score, Meteor, Route 1, Route 2, Routegel, and VLU using precision, recall, and F-score measures. So, in order to compare various evaluation techniques, what we have done is actually we have taken a part of this data set. So how we have taken the part, we actually took different types of sentences. We have taken equal number of similar and dissimilar sentences, mix of highly paraphrased ones and the ones with similar tokens. Why we have used it? Because some of the techniques are actually biased towards uh, some kind of sentences. Like word score is more biased towards similar sentences. Meteor is actually biased more towards dissimilar sentences. So for equal judgment, we have used it. Coming on to the results, after implementing all these techniques on this data set, we found that F score, which is actually less biased, Routegel has the best performance, and other word score and Meteor, although they are used for evaluating automatic abstractive text summaries, they have the similar performance. Why they have similar performance? Because we have taken equal number of similar and dissimilar sentences. So they perform equally. If they were unequal, the result would have been different. It would have been biased. So this is the graphical representation of the results. Look here, Meteor performs better. It is 1. And here, word score is recall oriented. It performs better over here. Coming on to the conclusion. The final conclusion after analyzing these techniques is that we can conclude that route technique is only suited for extractive text summarization as they calculate mere overlapping terms between the candidate and reference summaries. Coming on to BLEU technique, it also works on overlapping terms, n-grams actually. So, and it is also suited for extractive text summarization evaluation. Now, coming on to the two available techniques for abstractive text summarization, that is word score and Meteor. But the challenges we face while using them is word score has the problem of producing very high similarity scores, even for dissimilar sentences. If you take two dissimilar sentences, it will award a very high similarity score, even for them, most of the time. So, which leads to declaring many dissimilar sentences as similar. And moreover, there is a problem of antonym detection in word score. If you take two antonyms, good, bad, sometimes it awards a very high similarity score to them also. So it can't, it is very difficult for word score to detect antonyms. Coming on to the Meteor. Meteor is exactly opposite of word score. It produces very low similarity scores even for similar sentences, which leads to declaring similar sentences as dissimilar. Why it does so? Because it uses WordNet as its base, and not all words and most of the words are not present in WordNet when we use the actual data. So it simply awards 0 to such token similarity score. So that is how it is done. So final conclusion is, in the absence of accurate automatic evaluation techniques for abstractive text summarization, Raw gel continues to be the favorite choice among researchers for evaluating summaries. And the final words are we can say that there is a lot of scope for research in the area of automatic evaluation techniques, especially in the area of abstractive text summarization, and more techniques need to be developed for better evaluation. Thank you. That's it, sir. Ma'am.
Yes, I have a question for you. Thank you for your presentation. Now we have large language models like the ChatGPT. So why is it still necessary to develop individual text summarization tools? Could you explain it for me?
Sorry, his voice was low. I was not able to hear. Can you repeat your question, sir?
Oh, okay. Now we have large language models. Do you think is it still necessary to develop individual text summarization tools?
Yeah, actually, like Chat GPT and all these text summarization tools are actually present, but they have their share of problems. Like sometimes they hallucinate, and sometimes some problems are actually faced by them also, although they are being trained so much. So, but we have this share of because we can't go for only training. We need rule-based plus training for better results. So I think there should be a balance between the two.
Okay, thank you.
Okay, based on your analysis, do you propose any modifications on hybrid models for better evaluations?
Okay. Yes, ma'am.
How can your findings support the development of better summarization tools for real world applications? Can you hear me?
Yes, ma'am. Actually, I propose that there should be a hybrid model that is rule-based also and trained also. Because blindly we can't follow the training process. We need some human, like humans have intuition, and plus we have learned so much. So there should be a balance between the two. A hybrid approach will be, I think, better. That's it, ma'am.
Okay, thank you.
Okay. Any
Thank you
more
for your
queries?
presentation, ma'am.
Okay.
Moving on next, I'd like to call Ms. Aditi Kulkarni for her paper titled Design and Implementation of Orthogonal Frequency Division Multiplexing Transceiver Using FPGA. Ma'am, can you please start with your presentation?
Yes, ma'am, sure. Shall I share my screen?
Yeah.
Is my screen visible?
Yes, ma'am.
Okay. Hello everyone. Firstly, I would like to thank ICTIS team for this opportunity. I'm Aditi Kulkarni and my co-authors are Professor Chaitra, Ms. Preeti, Priya and Sana. Today I'm going to present our project, Design and Implementation of Orthogonal Frequency Division Multiplexing Transceiver using FPGA. So this is the overview of the presentation. So coming to the introduction part, OFDM, it is a combination of modulation and multiplexing, and it is a method of encoding the digital data on multiple carrier frequencies. OFDM splits a high-speed data stream into many lower speed substreams and transmits them simultaneously over multiple closely spaced subcarriers. Here we can observe the concept of OFDM. The subcarriers are mathematically orthogonal, meaning they don't interfere with each other even though they overlap in frequency. This allows the efficient use of bandwidth, and this concept is also uses fast Fourier transform, that is FFT and inverse FFT, to modulate and demodulate the signals efficiently. By spreading the data across many subcarriers, OFDM is robust against the channel impairments like inter-symbol interference, and it is used for high spectral bandwidth. So the problem statement is, in this era of 5G and beyond, nowadays 6G is also coming new technology in the wireless communication. The high-speed data transmission, spectral efficiency, and resistance to interference, they are the critical requirements for the wireless communication. And orthogonal frequency division multiplexing, that is OFDM, this has emerged as a fundamental technology to meet these demands due to its uh, resistance to the multipath fading, its high spectral efficiency, and its robustness against the ISI. So, coming to our project objectives, there are three objectives mainly of the project. That is, implementing we are using a QPSK modulation technique for this implementation for the OFDM framework, and converting the digital input, whatever we have, the input data into a phase shifted signals that corresponds to QPSK symbols. One will be having in phase, and one more is quadrature phase. Then the second objective is mapping the QPSK modulation, IFFT, and related OFDM components into Kintex 7 FPGA. That is, DSP slices, LUTs, and memory utilization is done. Then coming to the last objective, taking the whatever output of the FPGA, then giving it to the receiver module, then we can
Not
recover the.
visible. Richa ma'am, is it visible to you?
Sorry, ma'am.
Now it is visible. Yeah. Okay, continue.
Yes, ma'am. Coming to the last objective, taking the output from the FPGA, we are giving it to the receiver module that will accurately recover the transmitted QPSK symbols by applying the FFT to the received OFDM signal, and it will convert into the original data stream. Then these are the literature surveys we have done for our project, taking the account of different papers which are previously done. But onto the Kintex 7 FPGA board, we are the one who has implemented this concept. Then coming to the proposed methodology, we have used the uh, transmitter and receiver modules, and we are implementing these two modules in the MATLAB, which is the software tool used. And then coming to the FPGA part, we are using the Xilinx software, that is 18.3 version. Firstly, we'll be giving the transmitting the data signal into the MATLAB, and using Fourier transform model and IFFT models, we are converting the data signal into the modulated signal and IFFT signal for the channel coding and decoding. Then IFFT is used for modulation, followed by parallel to serial conversion, adding the cyclic prefix and interfacing with that to the FPGA board. Then the receiver model, FFT, is used in the demodulation, followed by serial to parallel conversion. We can easily understand through this block diagram. Firstly, we'll be giving the 16-bit input data into the MATLAB. Using the modulation model, we'll be converting the data into the QPSK signal, that is QPSK symbol of m equal to 4, that will be using 0, 0, 0, 1, 1, 0, and 1, 1 are the symbols. Then this will be the parallel input to the IFFT model, and the NFFT is used as 64, that is a 64 digital output will be getting. Then since this output is the analog output, we will be converting this into the digital output, so that it is compatible for the FPGA board. Then after implementing into the FPGA board, we'll be using doing many analysis that will be shown in the further slides. And same, whatever the transmitter model will be there, inverse that will be done at the receiver model in the MATLAB. Then digital to analog conversion will be done, FFT will be done, and demodulation will be done, and finally the original data what will be there, that will be received at the receiver. So as I said, we'll be using Xilinx Vivado for the FPGA implementation and design and analysis, and MATLAB or Simulink will be used for the transmitter and receiver module. Coming to the results, I said that we'll be giving input in the MATLAB. These are the like sample inputs. So we are giving in the MATLAB, and here QPSK modulated signal. We can see
Sorry
which are
for
the complex numbers.
sorry for interrupting, but
Yes.
around 9 minutes are over. Can you please wrap up?
Yes, ma'am. Come, these are the results and discussion. So we can see the mat plot, and this is the simulation in Xilinx Vivado for the FPGA board. And these are all the analysis we are doing here, like schematic. This is the schematic with the debug core. So this is the floor planning we have received in the Xilinx software. This is the IO planning. And this is the pin assignment, and these are all the implementation and synthesis analysis, and finally this is the utilization analysis, like how much DSP, LUTs, memory is utilized. So this is the main power analysis we'll be doing using the FPGA. Like why FPGA is used means like pipelining, clock analysis, and coming to the comparison with other board, we can see the efficiency which is very high using our FPGA board. So using this real time like temperature analysis also will be doing. Then here we can see that original output, like whatever the signal we have got, we can see at the receiver side. So final outcome is like ISI will be analyzed, like intersymbol interference will be resistant, and IFFT, FFT always they will be compatible with the this OFTM. So these are the main advantages and applications of the OFTM. So these are the references we have used. Thank you so much, ma'am. Any questions?
Yes. Do you can plan to scale the implementation of MMIO OFDM systems in future work?
Yes, ma'am. We can use the like OFDM. We can use the MIMO operations and all. So I
Okay.
think we can scale this project towards still more. That is also the like computation of bit error rate, signal to noise ratio, peak to average power ratio. Then already we
Okay.
have measured the spectral efficiency right now.
Okay. Have you considered power consumption and how it can be optimized for low power communication devices?
Yeah, coming to the power consumption, ma'am, we comparatively with other FPGA boards, actually our like we choose this Kintex 7 FPGA board so that it consumes very low power other comparatively to other boards, but still we can optimize the power utilization so that like it will be dependent on the number of inputs that we'll be using. For now we are using 16 input data for the digital signal. Then if we still use like vary the input data or input bits, then power optimization can be done, ma'am.
Okay. And last question, how flexible is your design for adapting to different communication standards like LTE, Wi-Fi?
Yes, ma'am. It is used in like this can be used in Wi-Fi. That like specifically we can use in like 802.11. That is any configuration like A or G or N. Then 4G, 5G, that is also in a running position. Like 4G, 5G, we can see that OFDM concept is already in use. Then like for digital video broadcasting, power line communication, that it is meeting already the standards, so that it is already in use of 4G and 5G. But if we still like to scale, then it can be used in like coming upcoming technologies like 6G and all.
Okay.
That's it.
Thank you. Thank you.
Thank you so much, ma'am.
Thank you for your presentation, ma'am. moving on next, I'd like to call Ms. Kangana Lakshmi for her paper titled Development and Real-Time Implementation of Multimodal Control Scheme for Nonlinear Conical Tank Process. Ma'am, please can you start with your presentation? Ma'am, are you speaking? You're not audible. Hello.
Hello, now am I audible?
Yes, ma'am, now you're audible.
So screen is visible.
Yes, ma'am,
Yeah.
you can start.
Yeah, good morning, ma'am. Good morning, all. I am Kadaglashmi from NIT Calicut, Kerala. Our topic is development and real-time implementation of multimodal control scheme for non-linear conical process. Our paper ID is 495. And then our contents are mainly what are the research group and main objective, and what are the real-time implementation and conclusion. So main thing is when we go for non-linear system, designing of controller is a very challenging task because single controller cannot be able to control all the range of the non-linear system. So our idea is to many people are doing. The leader is in the nonlinear system, around some operating point, and they are designing the controller. But in that time, we cannot cover all the area. So we are proposing on scheme. That is, we are dividing the nonlinear system into many linear system, and we are designing the controller for each system and combining all the system and combining all the controller, giving the weightage of each controller. We can make control for all the operating region. This is our proposed method. So now when you for multimodal control scheme means actually we are dividing overall non-linear region into simple linear region. Then we are designing the controller. Then how to combine all the controller means combining controller, and we are taking controller output from all the controllers. So this is actually two methods are available. One is a hard switching method and soft switching method. Hard switching method means simply we are assigning one weightage one to the one controller. So at a time only one controller is giving controller action for whatever the errors are coming from that. Then when you are moving for other region means immediately you have to switch on to other controller. Then it will not give the smooth transition between the controllers. So we are moving on to the soft controller switching. Soft switching means we are giving weightage for each controller, and we are combining two or more than controller. Then it will act together at a time. So we are using that weighting using the weight scheduling algorithm, and this weight scheduling algorithm may be different gap matrix based function, that is trapezoidal, Gaussian, and Bayesian functions. So now it is easy to design the controller for any nonlinear system. Then the gap metric means actually for dividing the nonlinear system, we have to formulate some standard. That means one nonlinear system is how many regions we are dividing, whether 6 or 4. That one method is based on the operator knowledge. So when the operator can decide how many linear models we can use it. Then if you are using 10 models also, some models will duplicate another model. So we have to take which one is giving the exact relation between the process. So we have to use gap metric method to analyze the distance between the two models. If the two models are giving same output means we can reduce one model and we can select only one model. So we are using the gap metric method to analyze how many models we have to choose it for nonlinear system. Then weight scheduling algorithm. So we have to decide weight scheduler for each controller. So now we have written the algorithm to giving the weightage for each controller based on the current process variable. Then main objective is to develop the multimodal control scheme by considering the time delay system also, and whatever the physical constraint also we are considering, and we design the controller. So here the proposed control scheme, the main first method step is we have to decompose the nonlinear system into different linear system. Then taking the exact linear model from the number of linear models using gap metric method. Then designing the controller, local controller for each model. Then combining all the controller with weight scheduling algorithm to get the overall control action. Uh, this is our multi-model control strategy. If you see that we have dividing the nonlinear region to different linear region, and each region we have designed the controller, local controller 1 and 2, and by combining all the controller action, we have designed weight scheduling algorithm. Combining these things, and the controller output will be a single control output. It is going to the actuator and nonlinear system. So now using this method, the performance will be improved compared to the other single controller used. So we have proposed this method, and we have validated with simulation as well as real-time setup. The real-time setup is which is available in our lab. This is application lab, NIT Calicut. That is conical and spherical tank lab scale setup. Here we have considered only conical tank system. So first we have to analyze what is the open loop response of that conical tank system. Typically it is a non-linear. Next we have divided by giving the different operating opening of the wall and taking the different operating condition, we have taken almost 10 models from the open loop system. It's a pure real-time system. So we have taken the process transfer function model from the open loop data. Then this data, we have designed the model and validated with the real-time response. So almost it's closely it is matching. So it is we assume that the model is almost same as the process of the real-time system. Then now almost 10 models we have designed, but we have to reduce minimum number of less number of the models. So by using gap-metric method, we have to analyze distance between the consecutive models. So we are analyzing the distance, and we have taken, that is we have given one gap metric threshold value. So we have decided to take 4 models, that is a T4, T7, T9, T9. The gap metric distance is 0.12. So we have taken only 4 models from that model bank. So almost we have developed 10 model. From that we have selected only the 4 model. So we assume that this 4 model is able to control all over the region. Now next we have to develop the controller for each model. So we have used model matching controller design algorithm. Using that one, we have designed the 4 controllers. There is a PI controller we have designed. Then we have to design the multi-model weighting algorithm for combining all the 4 controllers. So now once everything is over, we have validated with the real-time setup. So in the real-time setup, if you see, we have given the different set point variations. These close to responses almost following that set point, whatever we have varied. And then controller also, it's a minimum control effort. It is able to follow the set point. So when we see the weight scheduled algorithm, at a time we have decided at a time 2 controllers are working. So when we are changing the set point, so the region is moving to another region, that time there is a smooth transition between the controllers. So when we see that blue color, it is going slowly from 1 to going slowly to 0. Then other one is from 0 to it is going move to 1 slowly. That is a smooth transition is happening between the controllers. This is our proposed method. So from that, the conclusion is we have designed the design and developed the multi-model control design algorithm for nonlinear system, and here we have validated with the conical tank process. So using this proposed method, there is a smooth transition between the controllers and the switching action between the controllers. So for using that one, the in IAC and IAE are reduced compared to the single controller we used. Then the transient performance can be further enhanced by using the different controls, that is fractional order controller and different control scheme, designing of control scheme also we can do that. So we have validated with the real-time setup which is available in our lab. So now the same proposed method can be applied to any nonlinear system by dividing the multiple operating region. So further enhancement, we can go to the multi-input, multi-output system, because here we have validated only single input, single output system. So we have to improve for multi-input and multi-output system, and the designing the integer control, we are moving for the fractional order controller also. So we can move on to the different control designing method also, we can use it. This is our proposed method. And these are the reference we have used for our proposed method. Thank you. So any questions?
No questions from my side. Thank you. Nice presentation, ma'am.
Thank you.
Thank you for your presentation, ma'am. Moving on next, I'd like to call Ms. Sumaya Ann for her paper titled Dimensionality Reduction and Summarization Techniques in Big Data Visualization. Ma'am, can you please start with your
Yes,
presentation?
yes. Thank you so much. Yes, my screen, are you hearing me?
Yeah. Please continue.
Yeah. Hello everyone, myself Sumay Jannat Anni. My paper title is Dimensional Reduction and Summarization Techniques in Big Data Visualization, and our paper ID is 414. This is our author's name. I'm the first author, and our second author is MD Asanul Kabir Hussain. Sorry. Yes. Sorry for the interruption. Introduction. Big data is rapidly growing across industries such as healthcare, finance, and retail. Traditional visualization techniques fails with high dimensional data. Visualization plays a crucial role in understanding trends and patterns. Dimensional reduction techniques help in simplifying data while preserving key information. Importance of visualization: it helps in understanding complex data set and reduces computational complexity while maintaining the key data relationships, enhances business intelligence and predict analysis. Now I'm going to discuss the workflow of the dimensional reduction summarization. There are 5 steps. First one is data collection, after that data pre-processing. After that, dimensional reduction, PCA, TSNE, and UMAP helps for simplify the data, and summarization, clustering, and sampling improve the interpretability. And evaluation is done based on the visualization clarity, computational efficiency, and user feedback. Dimensional reduction techniques. Principal component analysis, PCA. It's actually linear transformation, reducing correlated features. T-SNE, T-distributed stochastic neighbor embedding, preserve local structure useful for clustering. UMAP, uniform manifold approximation and projection, is actually faster than T-SNE, maintain both local and global structure. Summarization technique, clustering, K-mean and DV-skin groups similar data points, sampling generates representative subsets, improving efficiency and helping reducing computation while maintaining accuracy. So from this user feedback chart, we can see like PC has a moderate interpretability, like almost 5 out of 10 scale, and T-SNE is the highest interpretability, is almost 8 out of 10, and UMAP has a good balance between the accuracy and compatible efficiency, and its score is 7 out of 10. So user prefer T-SNE for local clustering but UMAP for scalability. So demographic and clinical distribution. Age distribution evenly is paired across different age groups. You can see in this graph. And diagnosed categories, diagnosis A is most frequent, impeding treatment planning. And the treatment, we can see like for the X is preferred due to effectiveness ability. 3 cluster for the PCA result came in clustering. Yellow, tail, and purple. So yellow cluster is tightly packed in low variant, and overlapping between the tail and purple may indicate common data properties. And this is the dimensional reduction techniques visualization. PCA here is preserve global variance but struggle in non-linearity. TSNE based for local clustering but high computational in cost. UMAP balance scalability but structure preservation efficiently. Performance metrics. So from this performance metric, we can see like PCA is faster. Like within 10 seconds, it uses 50 MB, but TSNI is the slowest, like almost in 20 seconds. A highest memory uses 300 MB, and UMAP is faster than TSNI but use moderate, like it use 150 MB within 50 seconds. So GPU acceleration can improve execution for large data sets. Application in industry, we can use it in healthcare for medical imaging, patient risk profiling, finance for fraud detection or market trade analysis, cyber security like anomaly detection, real-time monitoring, public relation, sentiment analysis, target marketing campaigns. Challenges in big data visualization, like high dimensionally increases complexity, computational cost rises with dataset size, redundancy and sparsity make analysis difficult, need for scalable real-time visualization frameworks. Limitation of dimensional reduction, like high cost. TSNI and UMAP are expensive for large dataset. Scalability issues like limited use in social media and cybersecurity. User feedback, like limited generalizability. Data focus less effective for unstructured data. Bias can introduce fairness issue in AI. Emerging dimensional reduction methods, like beside these three, there are some other methods. Like in future we will work on all these things, about more research about all these things, like for isomorph map for medical imaging, for MRI CT scan analysis, autoencoders like AE for social network user clustering, then large V's for social network, T-tide for cyber security. So future improvements for real-time processing, enable the faster decision making, scalability, better normalization for massive data set, and efficiency, faster low memory algorithm. Hybrid modes, like combine the reduction and summarization. So future directions, enhancing computational efficiency with hybrid modes, real-time big data visualization frameworks, keep learning based dimensional reduction, expanding method to unstructured data like text and images. So in conclusion, I want to say, like dimensional reduction or summarize are essential for handling big data. PCA, TSNI, UMAP are each offer unique advantages, and UMAP is emerging as a scalable and effective visible tools. And future researchers should focus on improving efficiency and scalability. Acknowledgements. So I want to thank my university and my teacher, Mr. Nemutullah Khan, regarding this process. He helped me a lot. And appreciation for my research collaborator, MD Asanul Kabir Hussain. These are the references we use in our paper for the research. Thank you. Any question?
Thank you, ma'am. Are there any plans to incorporate AI-driven or adaptive summarization methods in your future research?
Sorry, ma'am, can you please repeat that?
Are there any plans to incorporate AI-driven or adaptive summarization methods in your future research?
Yes, like in future, we need to like more focus on our aim is like more focus on the research in the like UMAP and the new tools. Like these methods are for when we going to use the big data. Like for these methods, we face like a little bit problem. So how to like solve these problems? So we want more research in future for the other like autoencoders, these models, and improve this paper like for other level. So this is our plan for future.
Okay. Okay. Thank you. Thank you so much.
Thank you, ma'am.
Thank you for your
Thank you,
presentation.
everyone.
Moving on next, I'd like to call Mr. Hussein Jibber for the paper titled Hybrid CNN and Machine Learning Classifiers for MRI brain tumor detection using interactive MATLAB GUI. So please, can you start with the presentation?
Do you hear me?
We can hear you.
Do you hear me?
Yes,
Yes.
we can hear you.
Okay. I'm going to give some summary about my work. The title of paper: Hybrid CNN and Machine Learning Classifier for fMRI brain tumor detection using an interactive MATLAB AB Designer GUI. We start by give introduction about work. Early detection of a brain tumor from MRI is crucial and effective treatment and care. MRI scans are hard to interrupt manually, we use AI can assist significantly. AI can potentially improve the accuracy and the speed of the brain tumor detection. This research introduced an AI framework for classification of fMRI, brain tumor, and convolution neural networks and machine learning classifier. The framework includes MATLAB application designer GUI for enhanced visualization and usage. So we give problem statement here. It is often difficult to find the disease area by eye in MRI imaging. Preferences maybe vary between various different doctors. Accurate and timely diagnostic is essential for treatment planning. Manual segmentation of tumor is time-consuming and reliable on user experience. There is need for fast and accurate techniques for fMRI brain tumor detection. So the goal of this work, first develop hybrid AI framework using convolutional neural network with machine learning classifier. Second, apply comprehensive pre-processing technique, sample scale, stripping, normalization, and so on, to enhance MRI image quality. Third, evaluate multiple classifier, for example, support vector machine, decision tree, LDA, LR, and KNN for performance in terms of accuracy and computational efficiency. Then design an interactive MATLAB AV Designer GUI to enable intuitive use by medical professionals. Proposed solution for this problem. The proposed method combine convolutional neural network with machine learning classifier. The classifier used in this work, 5 classifier, decision tree, linear discriminative analysis, logistic regression, support vector machine, k-nearest neighbors. And then combine all this work in GUI by using MATLAB. We use the dataset, BRAD's brain MRI dataset, 8,000 MRI image. We use it, 400 for tumor and 400 without tumor. Dataset, we used 4 categories imaging, T1, T2, T1C, and FLAIR. Apply some pre-processing step, the first step, resampling, intensity normalizations called stripping, registration, and then segmentation. After pre-processing CNN architecture, an improved CNN architecture is designed for brain tumor classifier. The architecture includes convolution and pooling layer. Convolutional neural network automatically handle onboard sizing of MRI image. As I said, we used 5 classifier, decision tree, non-parametric method for classification, learn simple decision rules by recursive partition in the onboard space. One of main advantage of this classifier, easy to implement, and disadvantage of this one, weak prediction strength and variance issue. Linear discriminating analysis LDA finds a linear combination of a feature to separate, used for classification and dimension reduction also. LDA calculate probability of category. Support function machine is one of the main important classifier, separate data points by clear gap, effect for classification using Kernel function. K nearest Kn classify data based on majority classes of its nearest neighbor. The choice of K is very crucial in this. We designed ABB designer to provide all of this work. Here we can go to see this GUI. First one, we create one folder for onboard data and second for output data. First section here is pre-processing step, as we said, 5 steps, and then classifier method selection. We have 5 classifier combined with computation unit. From here, it is select which one we use it, and after train displaying the train, we give the accuracy also, prediction, and FI score and recall. This is metrics also. Here it is section for visualization. It is original image with a pre-processing result. Here it is confusion matrix. Here it is ROC, area under curve. We can show the result here. It is this table. This table show the CNN. Okay, you hear me? It's okay. CNN achieved highest accuracy. Also here it is area under curve, ROC curve shown in this is near to 1. It is CNN and SVM 0.95 achieved. Also, another computational efficiency result. This is for one of metrics to evaluate the work. This is based on the table, CNN combination with SVM achieved 120, while CNN KNN achieved 60 minutes. We reflect all results by bar figure. Here it is, we can see the accuracy. It is achieved highest. Okay, another one, it is classifier or ROC also here. CNN plus SVM combination. Also, he's by training time, so it is longer. CNN and CNN with KNN, it is shorted like this. Hybrid model outform standalone CNN. CNN combination with the SVM suitable for offline diagnostic. CNN with the D3 classifier, with real-time uses cases. By using a GUI, it is very important and interoperability for clinical division. The ROAS AI framework effectively identify and classify brain tumor from MRI scan. The MATLAB ABB designer improve the interpretability, very easy and usability for the system. The GUI provide interactive visualization of a MRI scan and classification result. CNN combination with SVM is suitable for high accuracy. CNN with decision tree is suitable for real time. The framework improve diagnostic reliability, and support clinical decision making. Thank you for listening. Do you have any question?
Thank you.
Thank you.
Thank you for your presentation. I think you still need to validate the GOI with a user test among doctors or medical students. It's my suggestion.
This is for biomedical student work. It's important. It is in biomedical area, important for engineering, biomedical engineers, and radiologists also at the same time. It's important.
Okay, thank you.
Thank you.
Thank you for your presentation, sir.
Thank you. Thank you.
Moving on next, I'd like to call Mr. Scott for his paper titled On-Chain PageRank as Predictor of Revenue in Application to Airdrop Targeting. Sir, please can you start with your presentation?
Thank you. Okay, thank you, everyone. This is a paper that we've recently written at Octane Network, where we do analytics on the blockchain. Just as a quick reminder, blockchain, of course, is a distributed ledger that's secured by cryptographic protocols. And if you look at the internet and the blockchain, the key insight is that both are large directed graphs. In fact, they're not only both the same data structure, but they're almost the same size. So if we look at the size of the internet, 2.4 million websites in 1998, and in 2025, 200 million active websites. It's very similar to the size of blockchains. For example, there are 200 million active addresses on Ethereum, and other blockchains like Arbitrum and Optimism are smaller, but similar to historical sizes of the internet. There are differences in the blockchain in that transaction amounts matter for the blockchain. Times are relevant. Multiplicity is relevant. So there's actually more information for the blockchain than there is for the internet. And algorithms can run more easily on the blockchain than on the internet. In particular, the PageRank algorithm, which of course was published in 1998, and it's the original Google search algorithm, the Google search algorithm. This can run on the blockchain. And the way that works is that on the internet, we have pages and hyperlinks between pages. So that those are the nodes and the edges in the graph. And then the blockchain, we have addresses and transactions between addresses. And those are the nodes and edges in the graph. So exactly the same algorithm can apply to both. PageRank can apply on the blockchain. In fact, there's we also can weight the edges on, and we can weight nodes. This is called adaptive PageRank or personalized PageRank. And so the algorithm can be tuned very closely to the blockchain. Of course, PageRank, each address starts with an equal reputation, and at each iteration, reputation flows along the edges of the graph according to the transaction graph or the hyperlink graph in the internet. And the final steady state of that system is the PageRank. Bringing this back to a practical application, the first Arbitrum airdrop. An airdrop, of course, is if an entity, a company, or a person or another entity drops some tokens that have value to users of their service. So Arbitrum is a blockchain, and they have a token that has some monetary value. And to reward early users of that blockchain, Arbitrum just distributed their token for free to people who had used the network. Now, in these situations, some users try to Sybil attack the blockchain. A Sybil attack is when one user pretends to be more than one user. And so, of course, if Arbitrum is distributing a certain number of tokens and the Sybil attacker can pretend to be more than one person, then they can get more than their fair share of tokens. So Arbitrum went through a very complicated process of clustering and manual analytics and determined 24% of the 2.7 million addresses on Arbitrum were eligible for this airdrop. They had used the network enough and they were not attackers. Now, 22.4, slightly smaller number than that, 22.4% of those members or those users claimed the airdrop. So there was a small percentage that did not claim the airdrop, and those are actually an interesting cohort. But those 22.4% of users who claimed the airdrop accounted for 72% of first-year revenue in the network for the first year after the airdrop. So what this says is that the Arbitrum targeting was very effective, that by only having 22% of the users, we could have 72% of the 72% of the network. Now, if you were to rank the addresses by their page rank, left to right along the x-axis, and then take percentiles of that, then on the y-axis, the first year revenue, the percentage of the first year revenue is represented. So we said that Arbitrum was able to target 22.4% of users and get 72% of revenue. And in this chart, this is showing that without any clustering, without any manual analytics, we can get very close to the same result. If we have 22% on the x-axis, we get even possibly a little better than Arbitrum was able to get in terms of first-year revenue and revenue following the airdrop. So this is the central result, is that by using a very extensive manual process, Arbitrum was able to target to have 22.4% of the active addresses claim the airdrop, and they generated 72% in the following year, 72% of first-year revenue. However, if we do a simpler process of ranking the top 22.4% of the addresses active on Arbitrum by page rank, the contribution to first-year revenue actually increases over this manual clustering approach that Arbitrum used. The 22.4% of those users actually contribute 73.5%. So targeting by page rank very efficiently optimizes for future revenue. And we also tried this with the first Optimism airdrop, which happened in roughly the same time window, and it showed very similar results. I think the last thing that I'm going to point out before questions, let me just go through this slide before questions. I'm going to skip over some of the outliers. So a few questions that that this leads to is, can PageRank predict future activity even in more general settings? If there is no airdrop, just take the PageRank of the addresses and see if it predicts future revenue. Hyperparameter optimization in adapted PageRank. Of course, there are many hyperparameters. Finding the ideal damping factor, weighting scheme, personalization vector, and so on to target future value. Combining with other signals, other KNN classifiers, what kinds of other signals can augment the PageRank performance? And then, of course, there are many applications beyond revenue.
Around 9
Yes.
minutes are over. Can you please wrap up?
Yes, thank you. Okay, I'm going to just stop right there and move on to questions. Thank you. So if there are any questions. Okay. Thank you.
And thank you for your presentation. Thank you.
Thank you.
Any questions? No questions. Okay. Thank you for your presentation, sir.
Thank you, ma'am.
Moving on next, I'd like to call Mr. Dheeraj Patil for his paper titled Smart Sanitary Pad Dispenser with Integrated Disposal System, Enhancing Menstrual Health Access in Rural and Low-Income Areas. So please can you start with your presentation?
Yes.
Good morning, everyone. Am I audible?
Yes, ma'am.
Good afternoon, everyone. I am Nisha Nikam presenting our research on smart sanitary pad dispenser with integrated disposal system. This work in collaboration with Dheeraj Patil and Dr. Brajesh Mehta sir is supported by Terna Engineering College, Nerul, Navi Mumbai. Here's a quick outline of the presentation. Dheeraj, change the slide.
Yeah, right.
Okay, let's start with the abstract to get a brief idea of the system. In many regions, the combination of economical limitations and lack of infrastructure has left menstrual hygiene needs largely unmet. This research proposes a smart, affordable, and automated system that dispenses sanitary pad upon OTP verification and incorporates a built-in incinerator for safe disposal. This system utilizes a Raspberry Pi controller, motor drivers, and web-based integration for real-time pad count tracking and low stock alerts. It also includes an admin dashboard for monitoring dispenser locations, stock levels, and uses pattern. Let's move on to the introduction to understand the background and motivation behind this system. The everyday challenges faced by women during menstruation are often intensified by cultural taboos and inadequate facilities. In areas where basic menstrual hygiene is unavailable, women are often compelled to use unsafe alternatives, leading to serious health complications. Compounding this issue, improper disposal methods contribute to environmental pollution and poor public sanitation. There is a persistent gap in awareness, infrastructure, and accessibility that calls for an innovative and scalable solution. To address these gaps, this research introduces a smart sanitary pad dispenser with an integrated disposal system that ensures hygiene, accessibility, and environmental responsibility in a single automated platform. Let's now identify the key challenges that this research aims to solve. Despite various initiatives, many women still struggle with menstrual hygiene due to limited access to dispensers, high cost, and systemic neglect. Frequent shortages and unreliable availability force users to rely on unhygienic alternatives, increasing health risks. Even where sanitary pads are provided, the lack of organized disposal solutions results in unsafe practices like flushing and open dumping, which is harmful for both public health and the environment. Additionally, finding dispensers in remote areas is challenging, and most existing systems lack automation, real time inventory tracking, and remote monitoring for maintenance. To tackle these persistent issues, this research introduces a technology enabled framework designed to ensure dependable distribution, efficient operation, and responsible waste handling. We will now go through the key objectives this system aims to fulfill. The main objective of this research is to design a smart, sustainable system that addresses menstrual hygiene challenges through automation and innovation. Specifically, the system aims to develop an automated sanitary pad dispenser to ensure easy and private access in public and underserved areas. It is also integrate a safe and eco-friendly disposal unit using an incinerator to handle waste hygienically. It enables real-time monitoring of pad availability and dispenser functionality through digital tracking. It minimizes manual intervention by offering a user-friendly, remotely accessible interface, and ultimately to support menstrual health awareness, reduce stigma, and provide a dignified solution for women. Let's now take a look at the overall architecture of the proposed system. User role selection. The process begins with the user selecting their role, that is admin or a regular user. Starting with the admin, they enter their registered mobile number and verify via OTP. After authentication, they access the admin panel. Here, they can enter dispenser details like location, quantity, and add new dispensers to the map. And it is once it is submitted, the system confirms registration and the dispenser becomes visible to users in real time. Now for the regular user, they enter their mobile number and complete OTP verification. Upon a success, a map with available dispenser is displayed. By selecting find map, the nearest dispenser is shown with direction. At the location, they tap get pad, re-verify via OTP, and the machine dispenses a pad. The system then updates the stock count instantly. Now let's have a look into system architecture of disposal system. The disposal process begins when the machine is plugged into a power socket. The system checks the MCB status. If it is on, it activates. If off, it remains inactive. A blinking green light indicates the machine is ready. Used pads are placed into the incineration chamber and pressing the yellow button starts a 9-minute burn cycle. During this, smoke is vented through a metal exhaust pipe and ash is collected in a tray. Upon completion, the red light stops blinking and the machine resets for the next use. Now, let's understand how the dispensing system is implemented. To begin with, the system ensures a secure user flow. Users simply enter their mobile number and get a OTP is generated using Twilio. Once the OTP is verified, the Raspberry Pi activates a gear motor that dispenses a sanitary pad. Next, to ensure accuracy, an infrared sensor confirms whether the pad has been dispensed properly. The admin panel updates the pad count instantly and send automatic low stock alerts. To make it user-friendly, LED indicators show system status, green for ready, red when active. Meanwhile, the map interface is updated live, reflecting the dispenser's location and availability. Moving on to the disposal system, the system only activates when the MCB is turned on with LEDs indicating readiness and burning status. After the user inserts the use pad and presses the button, an IC555 timer triggers a 9-minute incineration cycle. The heater coil reaches between 500 to 800 degrees Celsius to ensure complete combustion. The smoke is safely released through an exhaust and leftover ash is collected in a tray. The system resets automatically after each cycle and requires minimal maintenance. Let's now look at the system performance and monitoring capabilities. So with Flask and Leaflet.js, users can see nearby dispenser on a live GPS map along with real-time pad availability. In terms of access, OTP verification keeps user data secure, and we have also tested RFID for future upgrades. On the admin side, the dashboard allows remote updates, dispenser tracking, and inventory control. Syncing all happens instantly after each pad is dispensed or restocked. Now I hand it over to Dheeraj to explain the further part.
Let us begin by understanding how existing systems work and how our system addresses their limitations. This research presents a smart sanitary pad dispensing and a disposal system that overcomes the limitations of existing solutions. Unlike manual or coin-operated dispensers, this system ensures secure
Excuse
access
me,
using
sir. Sorry to interrupt, but 10 minutes are over. Can you please wrap up?
Yeah, OTP based. This dispensing mechanism is fully automated with Raspberry Pi and L289 motor controller, improving efficiency. In conclusion, our system ensures easy access to center pads, particularly in unserved areas. It enhances security with OTP and GPS-based authentication while automating both dispensing and disposal. Additionally, the integrated web map allows users to locate nearby dispenser efficiently. Looking ahead, the system can be improved with biometric NFC access for enhanced security, AI-driven stock monitoring for better inventory management, and solar power sustainability. We have referred this research paper for our research. Yeah, thank you for listening to our presentation. Any questions?
No, thank you from my side.
Thank you.
Thank you.
Thank you for the presentation, sir. Moving on next, I'd like to call Mr. Vanson Noon for his paper titled Solving Capacitated Vehicle Routing Problem with Lower Bound Capacity Constraints Using Local Search Strategy. So please can you start with your presentation?
Today I present about our work about solving capacity vehicle routing problem with low bound constraints capacity using local search strategy. Now I present in outline. The first I introduce about introduction and problem description, and after that I present our methodology and our result. And the last now we conclusion and draw future work. So as you know, vehicle routing problem is a class of combinatorial optimization problem in transportation and logistics. The most classical VRP is the capacitated vehicle routing, where a fleet of homogeneous vehicle with capacity is route to serve all customers. In recent years, many variants of this problem has been developed based on practical application. And recently, a new practical constraint proposed for a multi-chip, multi-distribution center VRP problem is allowed on the capacity of vehicle by Park et al. In 2023. In that context, we can see some roads may be assigned to few loads due to the goal of minimizing transport distance. Zeros create an imbalance in vehicle workloads and profitability, especially for third-party carrier. So we can see zero maybe often load calibration or cancellation policy to the route. So it's, for example, we can move the point, the 15 points to route or the 11 point to route. And our contribution in our work, we first introduced a new variant of the capacitated vehicle routing problem with the lower bound constraint. And we propose an integer linear programming model and validate by using one optimization solver such as Ruby on small benchmark instance. And we propose a local search algorithm for solving it, and experiment on benchmark instance are performed to compare the performance of our proposed algorithm with several other methods. And we introduce about problem. We have a set of vertices including customer warehouse points from 1 to n and single depot 0. And we have a set of out. Travel distance from a point to another point is from point E to point G is the DEG. And each customer has a predetermined demand. And we have a list of homogeneous vehicles available at the depots to serve all customers. And the capacity of each vehicle must be in the range. The lower bound is the C underline and the upper bound is the C overline. And we need those vehicles to serve all customers where total travel distance is minimized. And in our algorithm, we use a local search strategy because local search strategy is an appropriate approach for solving many optimization problems in real-life application because its neighborhood typically have low computation complexity and at the any time we have get feasible solution is always maintained. Yeah. And in our algorithm, we use 4 neighborhoods. For example, relocate, cross exchange, or off move, and true off move. For example, you can see on the figure for an example of the move. And our algorithm, the first we generate an initial solution by assigning customer to vehicle randomly. And after that, we shuffle the use neighborhood list. And in each iteration, we explore all neighborhood to get the best neighbor. And if we have the better solution, we update the better solution and we reset the stable index. Else, if we cannot find the better solution, we count stable increase 1. And if stable is greater than max stable, we have back to step 1 for escape the place out. And if the stop condition is met, we have stop algorithm, else we back to the step 2. In our result, we conduct numerical experiment on some benchmark instance proposed by Ultra et al. In 2017. And we evaluate the impact of new constraints and the efficiency of our algorithm. We modify the 14 instance to fit our problem by adding a scale parameter alpha that determines the lower bound of capacity. And in this experiment, we compare between our model with the proposed local search algorithm. In our model shown by the optimizer solver such as Ruby, and we found that the best solution found by the proposed local search algorithm are equivalent to the optimal solution of our integer linear problem model shown by Ruby. And after that, we perform some experiment for comparison our algorithm with the state-of-the-art methods. And we found that the best solution found by Ultra et al. Are summarized from 3 algorithms, includes IRSST of Sumerian and USGS of Pisin and branching cuts of Viro. And we found that our proposed algorithm is competitive with the IRSSP algorithm on some instance, such as XN101K25 and others. In conclusion, in our work, we investigate a new variant of capacity vehicle routing problem with lower bound capacity constraints, and we propose an efficient local search algorithm to solving it. Our algorithm is experiment on adapted benchmark datasets and the effects of the new capacity constraint on our problem are investigated, and we reason our problem with some state-of-the-art algorithm. And our algorithm is competitive with some existing method on some instance. So thank you for your attention. Any question for me? Thank you.
Thank you so much.
Thank you so much for the presentation. Moving on next, I'd like to call Mr. Edward for his paper titled The Quality of Creating Multimedia Learning Systems, Taking into Account the Cognitive Characteristics of Students. So please can you start with your presentation?
Hello, thank you. Just a moment. Hello, everyone. Today I would like to talk to you about how we can make learning more effective through multimedia systems. Our topic is the quality of creating multimedia learning systems, taking into account students' cognitive characteristics. This research was conducted by scientists from three leading universities in Kharkiv, Ukraine, is Simon Kuznets University of Economics, Aviation University, and Karasin University. Why is it important? Just image. Some students learn better when they listen to lectures, others when they see graphs, and some learn when they do something with their hands. Modern education is increasingly moving online, and we need to adapt it to this difference. Have you ever wondered why some teaching methods work better for you than others? What we are going to talk about today? Just a moment. Now let's talk about what we wanted to achieve in this study. On this slide, you can see the main objectives. First, we wanted to integrate how students' cognitive characteristics affect the way they perceive multimedia content. For example, will a student memorize material better through a video, presentation, or practical task? Secondly, we set out to develop adaptive e-learning systems that adjust to these features to make learning more personalized. The third goal is to evaluate how effective these systems are, whether they really help students to be more engaged and achieve better results. We also wanted to study generational difference because today's students are mostly Generation Z, and their preferences are different from the previously generation millennials. For example, is it true that younger students want more video and less text? Finally, we wanted to provide practical recommendations for teachers and developers so that they can create learning materials that meet the needs to each student. Image. If you received lesson in the format that works best for you, that was our main idea. Let's start with theoretical framework. Our research is based on the theory of information processing, which is the idea of how our brains perceive, analyze, and memorize knowledge. For example, someone will remember a text better if it is presented as a diagram rather than just read. We took this theory and applied it into adaptive e-learning systems. What does this mean? These are systems that adapt to each student. We also took into account generation peculiarities. Millennials, for example, are used to long explanations and text, while Generation Z are people who grew up with gadgets and want quick, simple content with pictures or videos. Image. A student who watches a short video in 5 minutes and learns more than 1 hour of reading. That's why we have to take this difference into account when creating learning platforms. Now let's talk about how we studied this. We decided to group students according to their cognitive characteristics, how they learn best. To do this, we used a questionnaire based on Howard Gardner's theory of multiplied intelligence. This theory states that there are different types of intelligence. For example, linguistic intelligence for those who like words, or kinesthetic intelligence for those who learn through action. We collected data from students and used the Cummins algorithm to categorize them into clusters. This is a mathematical method that looks for similarities between people. And in this figure conceptual diagram of adaptive learning systems, you can see how it works. It shows how information about a student enters the system, is analyzed, and then the system offers their personalized content. For example, for a visual sociotype, it's graphs, and for an auditory sociotype, it's lectures. Let's move on the result. We asked students how they like to learn, and this is what we got. This figure preferences of engagement in learning show that 57.5% of students choose individual assignments. Why? Because this way they can work in their own pace without pressure from others. For example, a student with a mathematical and logical sociotype would rather solve a problem on their own than in a group. Another 32.3% said they like working in small groups of 1 to 3 people. This is useful for practical tasks where ideas can be discussed, and only 10.2% choose the standard method. That is when everyone learns the same way. This figure shows how important it is to give students a choice. Image, if you could choose how you want to learn, what it'll be. Now, let's see what format of material students like. Here is a few preferences for the presentation of education material. 65.2% of students said they like PowerPoint presentation. Why? Because they are clear, structured, and easy to follow the teacher's point of view. 35% choose annotations. This is especially popular among those who like dynamic content, such as short videos or interactive diagrams, and only 4.3% stayed with traditional whiteboards, which shows that modern students are more inclined to digital formats. Another interesting fact is that 75.8% of students want to study at home, where they can review materials at their own conveniences. For example, image a student watching a lecture recording in the evening, stopping it to think, and it helps them understand the topic better. This data shows that students want flexibility and content that fits their preferences. So, what have we found out? Adaptive systems that take into account students' sociotypes improve learning. If we know that some learn better with video and others with text, we can give them exactly what works. Our recommendations are simply teachers should personalize content, and developers should add more interactive, such as tests or simulations. Image a future where every student receives lessons created just for them. This could change education. And one more, since we are planning to explore how sociotypes influence career choice. Thank you for your attention. Do you have any questions?
Any questions? No questions, I believe. Thank you for your presentation, sir.
Okay, thank you.
I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of this conference. We'll be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I'd like to thank our session chair. This is a token of appreciation. This is for both the session chairs. This is a token of appreciation for chairing this session. On behalf of the team ICTIS 2025 and Global Knowledge Research Foundation and partners, thank you, sir and ma'am, for your valuable presence. So before we
Thank you,
end the
ma'am.
session, thank you. Before we end the session, I'll kindly request everyone to switch on your cameras for a quick snapshot. Okay, thank you everyone. Have a nice day.
Have a nice day.